alphabets. Okay, this is so. Good morning, all of you. So in the last lecture, we can start with the on Friday's lecture. We have already covered the arithmetic coding. So basically, arithmetic coding can be used for encoding and decoding one set of sequence, and we have to reduce the size of sequence. But whenever we can use this arithmetic coding for encoding and decoding, basically we can say that this particular method can be used with the help of three ways. So these three ways are nothing but we can say that these are the three formulas, and we have to use these three various formulas to reduce the code words. But one more important thing is that when we use arithmetic coding, so unique identifier or we can say that the tag is concerned. So tag it is nothing but we have to calculate for a given sequence it's a lower limit and upper limit. So initially my lower limit is a 0 and my upper limit is a 1. So initially we can consider this, and then with the help of that, similarly we can calculate the tag in encoding method, and by using that same tag in decoding method we have to calculate the particular elements. So likewise, the arithmetic coding process is going to be takes place. So within a short while, I'll just show you the slides. Then you can easily understood how the arithmetic coding process is going to be takes place here. So as I already said that arithmetic coding it is deals with the three techniques or three ways. Those three ways we are going to be used for the encoding and decoding. As well as arithmetic coding, it is used for dealing with the source with small alphabets or the binary source. And based on that, the particular process is going to be takes place. As as well as I already said that unique identifier. So basically, unique identifier it is used to distinguish the two symbols, and it is also called as a tag. So normally the value of tag it is lies between 0 and 1, as I already said that. So the unique identifier or the tag it represents its value in the form of fraction. So if we said that the tag lies between 0 and 1, obviously it's a tag value, it is nothing but the 0 point something we can say. So that's why we can define the tag value for lower limit L is equal to 0 and for upper limit U is equal to 1. Then we have used some general conditions. So we have represent your given sequence in the form of x1, x2 up to a xn. So it is represented in the form of x. Then we have represent the lower limit formula. So L raised to n is equal to L raised to n minus 1 plus into bracket u raised to n minus 1 minus L raised to n minus 1 into f of x into x of n minus 1. So this is for lower limit, and for upper limit it is u raised to n is equal to L raised to n minus 1 plus into bracket u raised to n minus 1 minus of L raised to n minus 1 bracket complete into f of x of n. So here where n is nothing but the length of sequence and xn is nothing but the sequence. For example, we have given the sequence, it can consist of three number 4, 5, 6, 4 at first position, 5 at second, and 6 at third. So here for 4, my n is equal to 1 and xn is equal to 4. For 6, similarly, n is equal to 3 and xn is equal to 6 likewise. And similarly, you can calculate the tag value. So tag value t of x, it is calculated in the form of u raised to n plus L raised to n divided by 2. So based on the final nth value, we can put to calculate the tag here, and based on that you can calculate the you can simplify all the equation, and every time you can calculate the tag for each and every element. Suppose your given sequence consists of 4 elements, so we can calculate the 4 tag value in the encoding process. Then final tag value tx you have to calculate by using tx is equal to u raised to 4 plus L raised to 4 divided by 2. So this is the tag value we can use for decoding process. Then how the decoding process is going to be takes place? So along with the encoding and decoding example, there are certain conditions are given, so we have to use those conditions during simplify the equation, and we have to calculate the values for tag, as well as you have to decode the sequences. But you just keep in mind, whenever you can use the decoding method, once you can avail the equation of L and N. So we have to put the values over there. X is equal to 0 to N, and you can observe whatever the value you have received for the tag. So is it whatever the given decoded given tag value for decoding, is it lie between that two? If it is lie, then we consider that that particular X is equal to value, it is your sequence number. So likewise we can do the arithmetic decoding. So this is all about the arithmetic coding and decoding. Then the next part is that dictionary coding technique. So as I already said that, so dictionary coding technique, basically dictionary coding technique, it is a type of lossless data compression technique. So basically it can be used for long phrases and long sentence. So as per the normal dictionary coding technique, it can maintain its dictionary index. So you just keep in mind, inside the dictionary coding technique, we have to maintain the index and its index value. So basically dictionary coding, it is having a two type. One, it is called as a static dictionary, and other it is called as a dynamic dictionary. So static dictionary, it is having a no change. So whatever the given dictionary is, you can given dictionary to you, you can use as it is. But in the dynamic dictionary, it is adaptive dictionary, or it is a changeable dictionary. As per the requirement, you have to update the dictionary. Okay, so there are two main types for the dictionary coding. One, it is called as a dynamic dictionary, a static dictionary, and other it is called as a dynamic dictionary. Then as I already said that static dictionary means no change, and the dynamic dictionary means it is having a some sort of change as per the requirement. So if you knowledge of source or a dictionary is already built on based off a default dictionary, the sentence is encoded. So you just keep in mind, for the type of various dictionary coding technique, if you have a knowledge of source, means source, it is nothing but it is one set given to you for encoding and decoding. So if you have a knowledge of that source, then based on that source, you have to build the dictionary, or either already the dictionary given to you. Based on that, uh, that default dictionary, you have to encode the sentence. So it is takes place in the static dictionary. So why I'm saying static dictionary means no change. So if whatever the source signal or the source sample given to you, it can consist of alphabet. So based on those alphabet, already if the dictionary given to you, if it is not, you have to implement the dictionary. So by using that default dictionary, you have to encode the sequence. So that kind of a process is going to be takes place in the static dictionary. As well as in a dynamic dictionary, simultaneously coding and the dictionary is done. So simultaneously coding and the dictionary is going to be done as per as the dynamic dictionary are concerned. So for example, we have seen here there are four types of dictionary technique. For static dictionary, we can see here diagram coder, and for a dynamic dictionary, we can see here LZ77, LZ78, and sorry, LZW technique. So static dictionary, it is having a diagram coder, and for dynamic, it is LZ77, LZ78, and LZW. All the dictionary coding techniques are so simple techniques. So we just go through the its properties and rule, so we can easily encode and decode with the help of given source or given sequence. So one more important thing is that dictionary coding technique, it is a one of the important point as far as your syllabus concerned, because in the last paper, for each and every question paper, there is a question on the dictionary coding technique. So here we can start the first type of dictionary coding. It is called as a diagram coder. So diagram coder, or it is called as a diagram encoding technique. So you can means if the source given to you, suppose my source consists of the alphabets. So if you are observe on your screen, so my source A is equal to A, B, C, D, R. These are the various alphabets given to you. So this is actually source. Based on that, my sequence is, there is a repetition of these alphabets. So if we use a diagram coder, so every time diagram coder always read a 2-bit character. This is an important thing you just keep in mind. As I already said that if my sequence can consist of a repetition of alphabets, so those alphabets are nothing but my source A is equal to A, B, C, D, R. So there is a repetition of these 5 alphabets. So when we encode the sequence by using a diagram coder, I just always read the 2-bit characters simultaneously. So based on the knowledge about the source, we build the dictionary as shown below. So if you are observe on your screen, there is a one table. So that table can consist of a code word and the entry. So as I already said that there is a repetition of alphabet present in the sequence. So based on that, I am calculating my source because there are only 5 alphabet present in the sequence, and based on that my source A is equal to A, B, C, D, R. So these are the source given to you, and based on that initially I just try to build up the dictionary, or either this dictionary is given to you. So suppose we can consider here already given dictionary, but if is not, then you can, how you can implement. So you just keep in mind, first of all you can rearrange those alphabet in the alphabetical order. So source A represent A, B, C, D, R. These are the 5 alphabets. So at the first place my entry is A. So I'm start, there are 5 alphabets, so directly I can represent the, for 5 alphabet or 5 bit I can represent only 3-bit code. So that's why my code start for A start from 000 onwards, the triple one likewise. Okay, so for A, here I am representing a 3 times A. For B, it's a 000. Sorry, for A, I am representing a 000. For B, I am representing a 001. For C, I am representing a 010. For D, it's a 011. For R, it's a 100. So these are the available source with you. Based on that, initially, I am just design the dictionary, or in other word we can say that this is already given dictionary to you. Then how you can encode the given sequence, because my sequence is differ from source, because source indicates how many alphabet present in the sequence, and those source alphabets are nothing but these alphabets are repeated in the given sequence. So encode the sequence. My sequence is A B R A C A D A B R A, or in other word we can say that abracadabra. Okay, abracadabra. Okay. So as I already said that in a diagram coder you have to make the group of 2. Okay. Okay. So this is a message given to you, abracadabra. Okay, so as I already said that in a diagram coder, you have to make the group of 2. So how the procedure is going to be takes place for the grouping of 2? So we can start with the first alphabet A. So here we can start with the A. So Egypt A is already encountered. Yes, we can say that A is already encountered if you can observe here, because A is present previously. So based on this code, A it is having the entry in the code. So A represent the 3 times 0 here. Okay. So A it is already present. Then moving towards the next, we can make the pair of 2. So here I am making the pair of 2 AB. So if I am observing the previous table, is it the entry of this AB up to here, up to R? No. So there is no any entry for AB. If I am making the group of 2, so next to R, my R is 100. So for AB, I am representing here, it's a 101 means 5. 101 for AB means 5. Then moving towards the next, sorry, moving towards the next R. So R, this is already present in the dictionary. Its the code is the 10 and 0. For R, I am representing 100. Moving towards the next, it is A. A is already present. Moving towards the next, it's the AC. AC, is it present in the previous table? No. AC is not present. So moving towards the next, for AC, I am representing the, sorry, AC, I am representing the code after AB. So A it is 451. So AC it is 6. So for that purpose, 110. AC it is represent as 110. Moving towards the next one is A is already encountered. Make the pair of 2. So if we make the pair of 2, AD it is next to 6. So my code of AD it is 111. So similarly, I'll just make the code of AD. It is a 111. Okay. Then moving towards the next AB. So AB, A and B, it is already present. AB, it is already present. Okay. So I am considering the code here for AB. So it is 101. Okay. So if I am observing the dictionary here, if I am observing the dictionary in the previous slide, so AB, AC, AD, these are the symbol we have recommend from the given dictionary. So this is all the dictionary given to you. Based on that, I am just encoding the sequence. So AD, it is represent here 3 times 1. AB, it is 101. But on a given dictionary, R is already present, A is already present, and for RA, is there any entry in the given dictionary? For RA, is there any entry in the given dictionary? No, because R is individually present. For RA, there is no any entry. So in this case, so you can represent the separate code word for this R and separate code word for this A, because the R and A both entries in the given dictionary, we can say both entries in the given dictionary. So for this R, I am representing here 100, and for this A, I am representing here 3 times 0. For this A, I'm representing here 3 times 0. So when I am combinedly together this sequence, then I am writing here like this. This is our encoded sequence 101, then 100, then 110, then 111, then 101, then 100, and then 000. So this is the sequence we have encoded here. So if you are observing on this slide, I am do the same thing. A is already present. AB is not in the means AB. It is having a group of two. So I am considering the group of two. So AB, it is 101. Moving towards the next R. It is already present. RA is not there in the given dictionary. So for that R, I am individually represent its code 100. Then moving towards the next A is already present. AC is not present. AC, it is having present with the given dictionary, so that's why I'm making the pair of two. Its code is 110. Moving towards the next, A is already present. AD, it is present in the dictionary, so its code is 111. Moving towards the next, AB, it is code is 101. R and RA, it is not a pair present in the given dictionary, so that's why I'm representing by using this same dictionary. You just keep in mind this is the default dictionary given to you, and based on that, whatever the sequence is, you just encode. So when you can encode, you just keep in mind whatever the rule said, that in a diagram coder you have to make the pair of two alphabets, or in other word, it said that it always read the 2-bit characters. But if the characters pair are not present in the given dictionary, then you can consider at that time, you can consider only one alphabet. So A is already present. AB is there, that's why I am representing the code of AB, it is 101. For RA is not there, so that's why I am considering individual R, its code is 100. For A, it is there, but AC, it is also there, so it is a pair of two. Then 110. A is there, AD is there, so that's why I'm considering AD. Its code is 111. A is there, AB is there, so that's why I'm considering AB. Its code is 101. Then moving towards the next, RA is not there, so individual I am considering R, and individual I am considering a 0. So for R, my code is 100, and for A, my code is 000. So my encoded sequence for given alphabets are 101, 100, 110, 111, 101, then 100, 000. So this is the sequence for given alphabet or given source, we can say. So likewise you can encode. Similarly you can decode for here. So you can observe the alphabet. For 101 it is a B, for 1 it is a 100, it is R. So in reverse order you can decode the same. So you just keep in mind, in simply diagram coder, already the build dictionary given to you in the given format. So by using that dictionary index, you have to encode the source simply. So that kind of a process is going to be takes place in the diagram coder. There is a dictionary given to you. So based on that, you have to encode the sequence. So this is all about the diagram coding. So this is the type of static coding, static dictionary. Moving towards the next, second type of dictionary, it is called as a dynamic or adaptive dictionary technique. It is also called as a LZ77 dictionary. So in the dynamic, as I already said, that there are three types of dictionary. So those three types are LZ77, LZ78, and LZW. So we can see those various dictionary types here one by one. So dynamic or adaptive dictionary technique, LZ77. So LZ77, it is also called as a LZ1 technique, or it is also called as a sliding window technique. LZ77, it is also called as LZ1 and the sliding window technique. So you just keep in mind why it is called as a sliding window, because it can be work on the window base. So basically, its a window can consist of a pattern, that is sentence or phrases. So we can slowly move or slide ahead. So that's why it is called as a sliding window technique. So as I already said that it is a window, so you just keep in mind that window can consist of a 13 bits. So you have to represent the various characters or the numbers inside these 13 bits. So window can consist of a fixed size, it is having a 13-bit size. So Out of that 13 bits, 6 are the LAB, it is called as a look ahead buffer, and the remaining 7 are the search buffer. So window can be made with the help of two things. One, it is called as a look ahead buffer, or two buffers. One, it is called as a look ahead buffer, and other it is called as a search buffer. So why it is called as a window? So basically a sliding window, window, it can consist of a pattern or sentence or the phrase. So we can slowly move ahead or slide ahead. So that's why it is called as a sliding window technique. So whatever the window given, it can be divided into two parts. So as I already said that whatever the window given to you, it can be divided into two parts. So basically the size of window is a 13 bit. So it can be divided in the two part. One, it is called as a search buffer, and other it is called as a look ahead buffer. So look ahead buffer represent LAB, and search buffer, it is represented here SB, LAB and SB, look ahead buffer and the search ahead buffer. Sorry, search buffer. So look ahead buffer, again it is size is fixed, it is having only 6 bit. Okay. So the patterns that are encoded already. So what is the function of SB and what is the function of LAB? So you just keep in mind. So SB consists of the patterns that are encoded already. It is placed in a search buffer. The pattern, those who are already encoded, so it is placed in the search buffer, as well as the pattern, those who are encoded or those who are used for encoding process, it is placed in the look ahead buffer. Whatever I am saying, so whether the patterns or alphabet, those who are already encoded, so it can be placed in a search buffer, and the pattern, those who are used for the encoding process, it is placed in the look ahead buffer. So whatever the encoding send it to decoder, it will send it in the triplicate format. So once you can encode the alphabet, so those alphabet in the triplicate or the triplet format, so that triplet format can be sent it for the decoding process. That triplet format can be sent it for the decoding process. So we can see here as well what is the triplet procedure is. So as I already said that LZ77, it can be used a triplet format, LZ78 it is used a doublet, and LZW use a singlet format. So that triplet format you can represent inside the greater than and less than sign. So it is represent the three alphabet. So these three alphabet are nothing but OLC. So O represent the offset, L represent the length of match, and C represent the code word. Keep in mind. So in LZ77, it is used a triplet format. So that triplet format are nothing but it indicates the function. O represent the offset, L represent the how many bit of length of how many number of length of match, and C for which code we does not have a match. So it is represent with the help of code word. So offset, it is nothing but basically it is the distance between of pointer from your look ahead buffer. Whatever I am saying, offset, it is nothing but it is the distance between of pointer from your look ahead buffer. So you just keep in mind whenever you can encode any kind of alphabet. So as I already said that those alphabet you want to encode, it is placed in the look ahead buffer, and those alphabet is already encoded, it is placed in the search buffer. So whenever you can place the encoded alphabet in a search buffer, and if the similar alphabet is present in the look ahead buffer, then we can say that there is a match between look ahead buffer and search buffer. So from the pointer, you can measure the distance from pointer towards that particular alphabet, at which position that alphabet is present. So it is nothing but the offset. So distance between of a pointer from your look ahead buffer, it is called as a offset. So we can see how you can calculate the offset, how you can calculate the length of match, and how you can calculate the code word by using this LZ77 dictionary coding in the encoding method. So we can use here one example. So it is used in the sliding window technique. Okay. Okay. So these are the required thing I'll just discuss here, and based on that you can start for the LZ77 encoding method. So we can see here both method, encoding as well as decoding here. Okay. So as I already said that, I'm again repeating a few things here. So LZ77, it is also called as LZ1 or sliding window technique. So why we can call as a sliding window? So basically in a LZ77, it can consist of the window of 13 bits. So window size of this technique is fixed here 13. Okay. So I'm representing a window here. So every time you can represent this window like here. So first, second, third, fourth, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, and 13. So you just keep in mind whenever you can use LZ77 and sliding window technique, every time you have to represent the window for encoding process as well as a decoding process. This is the first thing. So why it is called as a sliding window? Because you have to move ahead one by one, or move ahead based on the situation slowly, or slide ahead. So that's why this window is called as a sliding window. Then one more important thing is that, so as I already said that the size of this window is fixed. So it is having a 13 bit 13 size. Then if you are observe this window, so here is the pointer. So here is the pointer, we can say. Okay. So this pointer gets divide your window in the form of look ahead buffer and the search ahead buffer. So at the side of look ahead buffer, the size of ahead buffer is 6. So there are 6 places we can used here for the look ahead buffer. 1, 2, 3, 4, 5, and 6. So these are the various 6 places we can use for the look ahead buffer, and the rest of the 7, so it is represent for the search buffer. So whatever I am saying, when we use this process, so those alphabet you want to encode, it is placed in the look ahead buffer, and those alphabet it is already already encoded, it is placed in the search buffer. Okay, so this is the basic thing we have required, and with the help of that we can start for the encoding. With the help of that, we can start here for the encoding. So for encoding, my example is the given sequence encode with the help of sliding window or LZ77 dictionary coding technique. So my example is, my sequence is CABRACADABRA double RA double RAD. Okay, so might be there are 20 to more than 20 alphabets in the sequence. So this is the sequence given to you. So you have to encode the sequence here. So first of all, you can draw the window here. So that window can consist of various blocks. One, it is the look ahead buffer, and other it is the search ahead buffer. So you can start from first to next 5. So we are going to be use the 6 alphabet here. So it is placed with the help of same position number it is given in the sequence, we can place in the look ahead buffer. So once I am placed in the look ahead buffer, then the next term is that you have to calculate the triplet for the same. So how you can calculate the triplet? So triplet, it can consist of offset, length of match, and the code word. So for first, my first alphabet is C here. So for this C, if I am observing these all the 6, those who are already situated in the look ahead buffer, and for this C, is it the offset, is it the length of match at the side of look ahead search buffer? Is there any alphabet present in the search ahead buffer, search buffer? No. So for the C, there is no length of match, means 0. We have to represent the offset value is 0. Then length of match, how many bits are present and at which position we have to represent the length of match. Obviously my search buffer is empty, so that's why my length of match is 0. And for which code we don't have a match? So for alphabet this C, I don't have a match, so I am representing C of C. So for C, I am representing inside the greater than and less than sign 0 comma 0 C of C, means my offset value is 0, my length of match is 0, and for which code word, which alphabet I don't have a match? For C, I don't have a match, so I am representing it's a C of C. Okay, so likewise, my first encoded value is 00 C of C. So in the next step, again you can design the new window, but we have encoded this C. So this C can be placed in the search buffer because it is already encountered. So when you can place the C in the search buffer, the next alphabet it is slide ahead on the place of C. So here is A, then the rest of the alphabet we can copy here from A to C. So if you are observing the next window, we can copy those alphabet from A to C, and the rest of alphabet you can write down after the window. So my next alphabet is A. So this A I'm placed here. You just compare these two window. So what do you understand? So as I already said that initially you can draw the sliding window. It can consist of 6 bit for look ahead buffer and the remaining for search buffer. So initially there is no any symbol gets encountered. So from your sequence first 6 alphabet you can place at the look ahead buffer, and based on that you can calculate the triplicate. So my first alphabet is a C. So for that C, is there any match at the search buffer side? No. So I'm representing offset value is 0. How many, if there is no match, then there is no any length of match. So again length of match value is 0. And for which alphabet we don't have a match? So for C we don't have a match, so we can represent the C. So my first encoded value is 00 C of C. So then you can draw the new window. So you can place C in the search buffer side because it is already encoded, and then you have to slide slowly. So at the place of C previous window you can place A in the new window, and at the place of B you can place. So if you are observing from this to this, what are the changes? This C can be placed in the this C can place in the search buffer. A at the place of C, B at the place of A, R at the place of B. So likewise we have to slide ahead, and at the last, so next alphabet from first step it is copy at the place of first B. So likewise we can slide ahead. So by using this second window, again you can calculate the offset for the same. So for the second window, if I am observing only one symbol is encoded A, but I just try to find out the match for this A. Is it A is present at this sliding window side, search buffer side? No. So for this second A, is there any match? No. So that's why offset value is 0, means there is no any position, length of match is 0, and for which code we don't have a match. So for which alphabet we don't have a match, it is a C of A. So my second encoded value is 00 C of A. Similarly, in the third step, you have to update the window in search buffer. You can represent the two alphabet CA, and the next last alphabet you can update at the next position, and in the look ahead buffer slide one by one, and you can place the six alphabet over there. Then you in the third step you can try to find out the match for this alphabet B. So if you are observing here at the third place B, so is there any match from the search buffer? No. So for this B, again offset value is a 0, length of match is 0, and for which alphabet we don't have a match? It is a B. So my next sequence is a 00 C of B. Similarly, in the next case, you have to update the window likewise on the fourth place. So in the search ahead buffer, there are three alphabets C, A, B. Take the place of B by R. Also slide one alphabet inside in the look ahead buffer. Then you just try to find out the match for this R. You can try to find out the match for this R. So there are three alphabet in a search buffer C, A, B. Is there any match for this R? No. So for this R, my offset value is 0, my length of match is 0, and for which alphabet we don't have a match for R, so C of R, so my encoded value is 00 R. So again that R you have to update at the next next stage of a sliding window. So my sliding window can consist of C, A, B, R, A, and you have to update the look ahead buffer, and B can be take the position of A. So likewise you have to update. So my look ahead buffer can consist of A, C, A, D, A, B, and my search buffer can consist of A, B, C, A, B, A, R. Okay, so for this R, okay, so whenever I'm find out the match for this A, so if I am observing the search buffer from this point, so this is the pointer we can say, because that pointer can divide the search buffer and the look ahead buffer. So this place we can call it as the pointer. So from this pointer at the which number of place that match is find out. So this is the first, this is the second, and this is the A present at the third position. So offset value for A is 3. Then how many number of bits the match is possible? So we can't consider that C because we have the offset value 3. So for that purpose we just compare only these three things here. So only for this A, I'm find out the match at the third position. So my offset is a 3. So only once time I match is find, and for which alphabet we don't have a match. My next alphabet is a C. So for this C, I don't have a match. So I'm representing the encoded value for A. It is the 3 1 C of C. 3 1 C of C. So you just keep in mind whatever I am saying here. So similarly, you can do the same thing. So I am repeating the same thing again here. So once you can design the window, we just try to find out the match for this A. So this is the pointer for find out the match from the search buffer. E, is it present in the search buffer? Yes, it is present here. So from this pointer at the which location A is present, so it is present at the third position. So we can represent the value for this A. The value of offset is 3. Then at for how many alphabet the match is possible or present. So if I am observing here for this A, only single match is possible. After that BR, and after that A there is a CA, so there is no any match. So we can say that only for A single one match is available, and for next alphabet is a C. So for this C, is there any match? No. So my next code word is a C. So for that there is a no match. So we can represent the next encoded value. Here it is 3 1 C of C. So you have to update the window here. Instead of a 2, there are the two, instead of one there are two alphabet you can represent inside the search buffer. So these two alphabet you can represent inside the search buffer at the next position. So I am representing these two A and C simultaneously. So these two alphabet you can insert in the look ahead buffer. So I am placing here. So my search buffer consists of C A B R A C. So next alphabet is A D B A R. So I am just try to find out the match for this A. Okay, I'm just try to find out the match this A. So A it is present at the second position, as well as A it is present at the fifth position. So we have find out the two match for the A. But I'm observing after that this A, the next alphabet is D, then A. So is it at the fifth position? A, D is present, no. At the second position, D is present, no. So to increasing the, instead of increasing the offset value, I am just consider the smallest value here. So for this A, my length of match here is, sorry, offset is a 2, and for this A, my length of match is 1, because after that D, so D, it is having a no match. So 2 1, for which alphabet we don't have a match? So C of D, this alphabet we don't have a match, so we can represent the offset here. So in the next window also we can update the two alphabets there. So again, one more important thing is that when we update the next window, we said that the search buffer it is size having the 7 bit. So we can update likewise A and D in the search buffer side. So here you can represent only 7 bit, and the first bit is it is come outside of that window. So likewise you can represent over there as well. Okay, so it is come outside of this window. So once you can represent this, then you have insert the last two alphabet in the look ahead buffer. So that RR I am representing here, and then you just try to find out the match simultaneously. So if I am observing this A, B, R, A, so here A, B, R, A, four sequences there. So if I am observing this, so same four sequences there, but A it is present. This is the first match we can say, or we can find out the match for this A. So A is present second position, fifth as well as this seventh position. So I am used this because after that there is a conjugate letters are come as per as the encoding sequence are concerned. So I think there is a time is over. So this remaining thing along with the decoding thing we can see in the next lecture. So till then, goodbye. So remaining thing we can cover in the next lecture. So meanwhile, I'm sharing the attendance. Everybody can submit the same. So rest of the things, it is very easy. So you can home also you can observe the same thing or try to cover this thing. So you can see the rest of thing in the next lecture. Thank you.